thanks for coming. We really appreciate your being here. We know there are other sessions you could go to, and very wonderful presence. My name is Deji Akomolafe. I'm a staff solutions architect at VMware, and I'm the practice lead for Microsoft application virtualization on vSphere. I have probably spoken to many of you on the phone before, and have probably been at your company, helping you understand how to best architect the vSphere infrastructure for optimum performance for Exchange Server. And with me today is...
I'm Michael Webster, otherwise known as WebScale Webster. I'm a performance engineer from a WebScale startup, but I work from home based in Auckland, New Zealand. So right now I'm upside down from down under. So it's great to be up in Europe again. I'm better known for virtualizing any monster virtual machines, any Microsoft or Unix applications on the vSphere platform. And we're going to be going through some hardcore performance data for you this morning. Who likes hardcore performance data? Yes, excellent.
It's good. So since you started on that, by show of hand, how many of you run virtualized Exchange server infrastructure?
Wow, excellent.
Awesome. And how many of you are happy with it?
That's good too.
Yeah, all right, good. So for those who are happy, you can leave now. All right, so we are required, so the lawyers say we have to tell you this. We can reveal some things that we don't want you to hear. If you hear it, please ignore it. Microsoft applications combined are the #1 virtualized application on the vSphere infrastructure. We've been doing virtualization of Microsoft applications for a very long time, even before you had mainstream support for those applications. And we have a lot of groups, IOUG, users group, VMworld, SQL Pass, SQL Saturdays, dedicated to everything Microsoft applications and business critical application as a whole. I know that many of you are familiar with those. You can get more information on how to do XYZ at those forums. So we're just letting you know there are hands-on labs sessions out here, and there's so many group discussions here. Outside of these current presentations, you have other opportunities to learn more about virtualizing business critical applications. Today, we are going to try and answer all of your questions if you're wondering whether or not the vSphere platform is a suitable platform for your Exchange virtualization project in this particular session. All right.
Can you just go back to that previous slide? Can't get away with that. Come on, keep going. Go back, go back. So one thing I didn't mention is that we got some great books in the VMworld bookstore. And if you want me to sign the Virtualizing SQL Server with VMware book, I'm one of the co-authors there. I'd be happy to sign it for you. Just tweet me, VCDXNZ001. So there's some great books down there. And there's an Exchange book there somewhere as well.
Okay. We are going to get started. And please, for those of you that have virtualized Exchange, or those of you who know what we're talking about, please stop us if we're getting too deep into, or if you've heard it before. We don't mean to flog a dead horse, but we have to repeat some things that you may already know. Okay? Microsoft supports Exchange server virtualization without any qualification. Okay? Every role, every component of Exchange server is supported. If you're wondering whether or not it is supported, categorically we are telling you right now. If you want link to substantiate that, they're over there for you. Everything we've provided in these presentations are publicly available, so there is nothing that is unofficial. Contrary to any public statement that you may have, people may have opinions, and they may tell you, well, we don't think you should do this. Ask for technical validation of such opinions. They are not facts. There is misinformation, there is disinformation. Always demand official written statement from anybody telling you that you cannot virtualize your Exchange server. There is no restriction, there is no exception. Let's talk quickly about the preferred architecture. Anybody heard about preferred architecture? Yeah. So Microsoft's way of running Exchange server, they take the position that your Exchange server should be on physical servers. which is good. It is their preferred way of running Exchange. It doesn't mean that that's the way you have to do it. And again, I will repeat, you will never find a document, a public document from Microsoft that says you cannot or should not virtualize Exchange. If anybody makes that statement to you, please demand official written statements to that effect. All right. Don't take our word for it. I'm standing here, Mike is standing here with me, and we're telling you Exchange is good. I'll go and virtualize it. Don't take our words for it. We would like for you to listen to the expert and what they have to say about virtualizing Exchange. And we've provided all the links here that you can take with you in case there is any contention. Okay, for deployment of Exchange, these are directly from Microsoft. I'll let you take a quick glance at that. The esxtop platform has been certified, has been SVVP compliant and certified for a very long time, since 3.5. And we continue to be one of the certified virtualization platform on the SVVP program. Okay. vSphere itself meets all the requirements. Microsoft has strict requirements for virtualizing Exchange workloads. vSphere meets all of those requirements and some more. Okay. And these are the requirements. You may be told that if you virtualize your Exchange server, do not use some features like DAG, or don't use some features like DRS vMotion. We're telling you, you can combine all of those things, the native high availability features of Exchange with the native high availability features and resilience in vSphere. You can combine them together and you will be supported. There is no restriction. There is no do not do this when you virtualize Exchange. And if you want to hear more about it, again, the links are there. We agree with Microsoft. These statements are from Microsoft. We agree with them, and we tell you that vSphere, vMotion, and DRS are compliant with every stipulations made by Microsoft as to supportability of Exchange server virtualization. All right. Now, we spent about 5 minutes talking about assuring you that it is doable, that you can do it, but why should you do it? Let's make the case for why should you virtualize your Exchange server. There are several improvements in Exchange 2013, several improvements in vSphere 6, vSphere 5.5 that lend themselves to virtualizing Exchange server rather than running it on physical. Improvement in performance, improvement in availability, improvement in capacity. If you virtualize Exchange, you can use that opportunity to consolidate your Exchange environment without going multi-role. We have some things we can talk about multi-role configuration, which is one of the options presented in Microsoft Preferred Architecture. We say that you could use the same number of hardware to optimally support your Exchange infrastructure without having to combine the roles. You don't have to have CAS and mailbox servers mixed together on the same server, where a problem that's related to CAS will require you to reboot a system and take down the mailbox server role. You could separate those two onto multiple VMs and still have availability. So one negative impact on one role does not affect the other role. If you want to combine the roles together, you can do that also on vSphere. We do not have any restriction whatsoever on doing that.
Can I give an example, Deji? So we mentioned just before that Exchange has been supported essentially on vSphere since 3.5. Does anybody remember back to 3.5? Yeah, me too. Now, one of VMware's big customers in terms of Exchange consolidated from 100 data centers down to 40 when they virtualized 700,000 Exchange mailboxes on esxi 3.5, a long time ago. Now, that customer has since upgraded, and they're still running one of the largest private Exchange deployments on the planet, serving up to 2 million staff out in the field across the globe. And it's all virtualized on vSphere.
Thank you. Does anybody know where that comes from? That's the Exchange calculator. Thank you. All right. Why do we say virtualize Exchange server and that you can utilize the hardware more efficiently? If you're familiar with the Exchange calculator, and if you've been following all the white papers and releases from Microsoft to date, you will know that on a physical server, Microsoft recommends that you do not have a mailbox server that has more than 24 CPUs. The mailbox server, with all the rows combined, cannot have more than 96 gig of RAM. When you buy hardware today, it is very, 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 very likely that that hardware will have more than 96 gigs of RAM. If you put Exchange on that, Exchange will suffer performance degradation. It is not a theory. It is documented by Microsoft, and the link is there. So this is the recommended prescriptive design guidance taken from Microsoft documentation. And if you look at that, and if you look at the prescribed utilization, you're going to have about 46% worst case usage, okay, maximum usage. And what happens to the 54% of the resources available? It will be wasted. On a vSphere infrastructure or in a virtual environment, that 56% resource can be utilized for other workloads, can be utilized for other Exchange servers. You can consolidate more efficiently if you virtualize, because your modern hardware cannot be fully utilized by Exchange, and it will introduce performance degradation. That is not a conjecture, that is a statement from Microsoft. Virtualization, as you all know, improves agility, ROI, TCO, and all that. It saves you money. vSphere high availability features like DRS, vMotion, HA do not take anything away from Exchange. They complement Exchange native availability. Okay, so you don't have to forgo one for the other. All right, all good. I just assured you that Microsoft supports it, that you can save money if you do it. What happens if Microsoft says no, or you run into a support issue? You're covered. We have multiple ways of providing support to you. We can guarantee you that Microsoft would never say you run Exchange on a virtual environment, go away, we won't support you. That would never happen. But just in case, you still have support through our support GSS, Global Support System, and you have support through your OEM. Just in case any of those three don't work, and you need support for your virtualized Exchange server, you're covered also under a fourth category of support called the TSA Net. The TSA Net is an alliance of OEMs and vendors all over the world, where they come together and say, if my customer does this on my application or on my product, and they have issues, and they call you, and you can support them, don't send them away. We have a back channel where we can provide support to the customer. You can leverage TSA Net anytime a vendor tells you that because you run this on XYZ, we will not be able to support you. The TSA Net, if you use the TSA Net through VMware, we will take the case from you and we'll work the case with Microsoft directly on your behalf. So you're covered in every aspect if you virtualize your Exchange server and you run into any performance issue or any support issues. Okay, I've told you all the good things, right? So then I'm sure since most people who have virtualized their Exchange server, you have at one time or the other seen some performance issues, right? Otherwise you will not be here. All right, so if we say it's so good, why do things go bad? All right, there are some misunderstandings. I say tomatoes, somebody says tomatoes. Microsoft, you will find some documentation that says disable hyperthreading, disable NUMA, disable this and disable that in some Microsoft publications, or some salesperson may tell you things like that. Please look at the clarification. We provided a link. That statement applies only to Exchange, Exchange that you run on physical. When you hear disable hyperthreading, when you hear disable NUMA, when you hear disable this and that, it applies only to Exchange on physical server. That link goes to Microsoft document that states that. Okay, there is no question of VMware is telling us something contrary to what Microsoft told us. All right. When somebody tells you to disable NUMA, please simply ask them why. Technical reason why I should disable NUMA. All right, there are limitations and constraints. I mentioned some of them, and I will go into deeper details later. Windows default behavior also introduces issues, performance issues to Exchange when you virtualize it. And let's be honest, virtualization is different from running things on physical hardware. So we will go through a little bit of what the differences are and how you can account for those differences so that you can have an optimal implementation. Fairness taxes is a concept in VMware, in vSphere, where we say when you virtualize workloads, the resources they utilize, they have to utilize it fairly. If they don't utilize it fairly, they pay a tax. And the tax is an imposition of performance. We slow them down a little bit if they're not judiciously using the resources you've given them. Because we pool resources in a virtual environment and we share those resources among many entities, we want everybody to have only what they need and not what you just want to give them. So there are some penalties. There are some penalties associated with non-efficient utilization of resources. We'll go through that shortly. All right, then there is the other thing that you will hear, layer H. Virtualization is complex. Well, maybe. But if you know it, then it's not complex. A surgeon will tell you that surgery is not that complex. If you were to go perform brain surgery, well, for you, it is complex. All right. Okay, let's clear up those misunderstandings. Okay, Microsoft recommends disabling hyperthreading. They clear that up. Okay, hyperthreading doubles processor count. This is why Microsoft usually recommended that you disable it. Let's go through a quick explanation. When you enable hyperthreading in vSphere, you will see logical cores that are twice the number of physical cores that you have. And some administrators will use that logical core count to size their infrastructure. And then they will remember, oh yeah, Microsoft supports 2-to-1 virtual to physical ratio. Then they will over-provision again. So now they have 4-to-1 over-provisioning. For business critical applications, that is not your objective. We want performance, we want availability. We are not shooting for consolidations when you're talking about things like SQL, Exchange, Oracle, and all that. So this is why usually you want to disable hyperthreading if you don't know how to understand that enabling it doesn't manufacture CPU out of the thin air. Okay. This is what I just described. We highly recommend, always recommend that you enable hyperthreading. Okay? And we always recommend that you size your VMs and your virtual resource allocation to the core counts on your physical servers. Now, after a steady state operation, when you realize that those resources are not being fully consumed, you can reduce the resources for the VM, which frees up more resources that you can then use for other workloads. So you could go theoretically up to 2-to-1. We support that, and Microsoft supports it also. Exchange is not NUMA aware. Exchange doesn't know how to use NUMA, period. But that doesn't mean that workloads don't know how to use NUMA. Windows knows how to use NUMA. So you do not necessarily have to disable NUMA because you're running Exchange in your vSphere infrastructure. If you don't want Exchange to use NUMA, we can disable NUMA for the VM itself. Okay. Windows is NUMA aware, even though Exchange does not know how to use it. NUMA does not hurt Exchange. Exchange just ignores it. It doesn't take the optimization. All right. Let's say you have to implement your Exchange virtualization and disabling NUMA becomes a hot topic that you can't get away from. Yeah, you can just ignore it. Again, you don't have to do it if you don't want to do it. We just say you could do host level NUMA, enable host level NUMA, and disable VM level NUMA for the Exchange VMs. Other workloads in the ESS cluster can continue to take advantage of NUMA, like SQL Server or anything else. Somebody taking selfies? By the way, you will get these slides.
Yeah.
All right, so moving on. So let's talk about limitations and constraints. Oversizing Exchange server is the #1 killer of Exchange virtualization project. If you give it too much resources, it will perform horribly. And those are the links where Microsoft discussed this. Windows default behavior, everybody who's a Windows administrator or administers Windows on a fairly regular basis will tell you that modern Windows OSs have one power scheme. By default, it's called balanced. The balanced power scheme is very bad for business critical application where you want to ensure performance. Why? Because balanced power settings is meant to save power and energy. It is not for performance. So what you will see if you leave it at the default balanced configuration is that occasionally Windows will turn off CPUs inside the guest. It's called core parking. It will park some of the cores because it thinks that they are not being used. And then when Exchange needs those cores, Windows will wake up the core and say, okay, now you can service requests. The turning off and the turning on is very, very bad for a highly performant workload like Exchange. Okay, it increases performance penalty. And that's why we recommend that you change your power setting. You change your power settings inside the guest OS to high performance. There's a tool that you can use also to check your current configuration with recommendations on improvement. All right, moving on. Windows default behavior with RSS, receive side scaling. Modern Windows OS also have two places where you make these settings. If it's disabled, what happens is that all network packets coming from that VM will be serviced by one processor core, processor 0. And if it's disabled, when processor 0 keeps servicing the network packet, regardless of how many CPUs you have in the VM, everything will be going to CPU 0. CPU 0 will be saturated, and then you will get a lot of packet drops. The packet drops you will not be able to see in vSphere. You will not be able to see in esxtop. Why? Because the packet drops are happening inside the guest. They are not making it onto the VM kernel, so we do not see it. It's very hard to troubleshoot, very simple to fix. Enable RSS on the virtual NIC inside the guest, enable it at the NIC property, enable it with NetSH. So there are two places to enable that. All right. Please stay with me here. I'm going to repeat myself many times. Why am I doing that? Because I field calls every day from Exchange administrators, Exchange architects like you, and every time somebody creates a support ticket and the resolution is not getting done very quickly, it gets escalated to my team. We see a lot of it. Somebody will say, I virtualized Exchange. It is running at 20% the speed or the performance level of when it was in physical. It must be virtualization. We'll go through and check everything from top to bottom, and we won't find anything. And then we'll go back and check the hardware, drivers, firmware, and BIOS. Please stay with me on this. Drivers, firmware, and BIOS refs are very, very critical to your virtualized workload. Combined together, they create more hardship for Exchange on the virtualization platform. If you are experiencing performance degradation, please always start at that level. Make sure that the BIOS drivers and firmware are up to date, and then we'll look at other things. I can tell you 80% of the time, we fix problems related to Exchange on vSphere by doing this. All right, let's do a quick bite. I'm going to run through this very quickly. You may hear occasionally when you approach maybe Microsoft people that you want to virtualize Exchange, they will tell you, okay, good, disable, what do they call it? Dynamic memory. There is no dynamic memory in vSphere. Dynamic memory is a process that takes away memory from a VM when there's contention, physically reduce memory size for a VM. There is no such feature in vSphere. So there is no dynamic memory. It's not a problem on vSphere. Exchange recovery requires cold boot. That's a Microsoft specification if you're going to virtualize Exchange, and you may hear other people tell you, don't use SRM, don't use DRS, don't use this because of this. We recover Exchange, we recover VMs from cold boot state. So we're compliant with our regulation. The calculator always, anybody familiar with the Exchange calculator? If you're going to do any Exchange implementation, that's your baseline. That's where you start from. You take the Excel spreadsheet, you input numbers, and it spits out something and say, this is how you size your VM. That calculator is always very, very generous. Okay, we recommend that you have that knowledge when you are trying to virtualize your Exchange and you're using the Exchange calculator. Snapshot, we do not recommend snapshot unless you're doing the snapshot from the array. Array-based snapshot, good. Right-click in vSphere, snapshot, bad for Exchange. You will corrupt your databases, I can guarantee that. All right. We already touched on hyperthreading. We're talking about differences, misunderstanding. Virtualization is not complex, it is different. Once you know how to do it, you know it's just like any other thing that you do for a living. Remember, we abstract the resources, we abstract storage. There is an abstraction layer, and you have to be conscious of that when you size and configure your Exchange infrastructure on vSphere. There are more potential bottlenecks. There are more places where we can slow down performance if you're not careful because you are abstracting the resources. We will go through that shortly. For example, if you create a lot of VMDKs, you attach them to one SCSI controllers, all the IOs coming from those VMDKs are going to go through one single controller. That single controller is a choke point. If you put 500 cars on the Autobahn, you will hardly see a congestion. If you put 500 cars on the one-way lane behind us here, you will see congestion. We will delve more into this very shortly. All right. Virtualization requires fairness. I mentioned that. Don't give Exchange more memory or more CPU than it needs. They pay memory idle tax. If they're not using the memory efficiently, they will pay taxes. The taxes is a performance penalty. It will slow down your Exchange. Calculator very generous. Exchange has a 96 gig RAM limitation. If you give it anything more than that, Microsoft tells you you introduce performance degradation into Exchange. All right.
My turn. Thank you, Deji. So queues are everywhere, and we're going to talk a lot about queues now and all of the different layers in the VMware architecture here. So the type of adapter is important. What type of adapter should we use for our virtual machines? There is only one answer. Power Virtual SCSI is the answer. That will give the lowest latency and best performance. And then, of course, we've got the VM kernel modules. We've got potentially the queue depth at HBAs, the fiber channel, and then the underlying storage. And all the way through, there is different queues everywhere. Queues inside the virtual machine for each virtual disk, for each virtual controller, for each HBA, and for each storage processor in the architecture. So we need to be sure that we can optimize the performance, but without causing a catastrophic performance problem somewhere else in the architecture with noisy neighbors and things like that. And really, nobody likes queues. So we've got some customers arriving, and they're all just waiting in line. And essentially, this is how the storage queue works for a single device in the operating system. Now, if you want to see a real example of how bad this can get, there's a photo on the internet called 50 lanes into 2. And it's a road in China where there's a toll gate and it has 50 lanes of cars, and then after the toll gate, it goes down to 2 lanes. Now, that is what can happen inside your virtual machines if they're not properly designed. So what we want to do is we want to have more parallel I/O going from the guest operating system to the hypervisor and then down into your storage, because then we can get more things done at the same time. And the way we do this is by having more virtual disks and laying out the databases and their log files across those virtual disks and across different Paravirtual SCSI adapters in your guest operating system. So what's the maximum number of SCSI adapters you can have? Anybody know? Answer is 4. Yep, and you can have up to 60 virtual disks at the moment as well, that you can split those across. So parallelism, people. It's what cool people do. And this works for Exchange just like it works for databases. Okay, so optimizing for performance, we have some knowledge base articles here that go through and give you the steps on how to modify the operating system, drivers, registry settings, and also the queue depths on your HBAs. But be very, very careful when modifying the queue depths on your HBAs. It can overload your entire SAN, and then everything else connected to it could have a very bad day. If you're using a new type architecture platform that doesn't have HBAs and SANs and things like that, then generally you won't have any problems of that nature. Oops. Okay, so optimizing for performance, making sure you're doing all the basics correctly. So follow your storage vendor's documentation on doing the basics correctly, follow the best practice guides, and that will set you up from day one to be successful. Okay, lazy zeroed thin versus eager zeroed thick. Now in the old days, there was a very big difference in performance between eager zeroed thick, normal thick and thin. And depending on your back-end storage system, there may be some difference or there may be absolutely zero difference now, because most of the modern arrays just throw away the zeros anyway when they're coming in, and there's absolutely no performance difference either way. So then it becomes a decision about, is it better to manage thick disks or is it better to manage thin disks? And how much effort and time do you want to put into that? A lot of the time it's more efficient from a management perspective to have thick versus thin, but again, it depends on your back end. Most of the arrays now use the VMware APIs for array integration, and they offload those zero processes. Okay, so some queue depth limits. As per 5.5, you can create 62 terabyte virtual disks. Is creating a 62 terabyte virtual disk a good idea? It might be, but generally that's not going to be your performance problem. The performance problem is the queue depth is still limited by the individual virtual disk. So you've got to be careful about those queues, but you can have up to 256 queue depth on an individual virtual disk if you're using PV-SCSI. And when should we use RDMs? There's only one correct answer to that as well, and that is never. Because virtual disks perform exactly the same, if not better than RDMs, and RDMs are just going to complicate things. And you've only got a limited number of LUNs that you can attach to a VMware host. So the only use case for RDMs is physical failover clustering, which Exchange doesn't use. So Exchange gets no benefit whatsoever from using RDMs.
Storage vendor?
Storage vendor snapshots and things like that may be at the back end. Yeah, unless they're integrated with the VMware APIs. Okay, so if you're running a large Exchange server, this is an example of how you should lay out the configuration to get the best performance. So you'll have your ESX LUNs, you'll have your or data stores, however the data stores are created. You'll have your log volumes, your data volumes, and they will be split up over multiple drive letters and multiple SCSI adapters. And that will give you the best balance of performance. Okay, making sure block alignment is there. Now again, this applies to some storage systems, it doesn't apply to all. A lot of storage systems now are smart enough that they automatically do the alignment for you. Most modern operating systems are also smart enough that they automatically do the alignment for you. So if you're running Windows 2008 R2 or above, you should not have to worry about this problem. And if you're using a modern storage system that's got modern firmware, you also should not have to worry about this problem. Okay, memory.
If you are if you have a policy of combining or co-locating multiple workloads inside one single vSphere cluster, If you have your Exchange, your web application, your middle tier, and other applications running VMs inside the same ESX cluster, you might want to optimize performance for the important workloads such as Exchange Server. If you do that, we recommend that when you allocate memory to the Exchange servers or to any critical VMs, please reserve the allocated memory. If you give the VM, say 32 gig of RAM, please reserve all 32 gig of RAM. Why? Because if there is contention in that ESX cluster, the VM that has the reserved resource will always have that resource available. It will not share that resource with anything else inside the ESX cluster. If you don't have over-provisioning going on, then you don't need to do reservation. But if you have over-provisioning going on, and there may be a potential for resource contention, please reserve the memory for the VM. The amount of memory will be guaranteed even under heavy load. Do not set limits on your Exchange VMs. Some customers, I'm not looking at you, like to deploy VMs from template, and they like to set limits on the template so that people can't misuse it. So they create a template with 8 gig of RAM, for example. They deploy Exchange mailbox server that requires, let's say, 32 gig of RAM from that template. They forgot to remove that limit. What happens is when you start running your Exchange, that VM will only be able to address 8 gig of RAM. You can go ahead and give it 5 terabytes of RAM. It will not be able to exceed that. And it's very difficult to troubleshoot because you're giving it more memory and it's still performing worse. Okay. Uncheck limit. Limit is limit. There is no way for you to exceed limits. Do not enable memory auth-add for Exchange. Memory auth-add is a feature in vSphere where you can just add memory to a VM that's running. Exchange doesn't know how to use it. You will have to restart Exchange services for Exchange to see the new memory. So if you're going to restart Exchange services anyway, why don't you just shut down Exchange and shut down the VM and just add memory? All right. This is an example of reservation and swap. In addition to the fact that when you reserve, we don't share the memory with anybody else. We also reduce the swap. We don't swap anything. So your swap file will usually be 0 or less. Network optimization. You have DAG. I would say 90% of customers who run Exchange like to run DAG. Microsoft recommends using just one NIC for both the heartbeat and the public traffic. That's good. It's okay. We support it. You can do it on vSphere, but we recommend that you split it out. Separate NICs for the traffics. We recommend that you have minimum of 4 NICs per host. We recommend that you enable jumbo frames if you are doing DAG, especially if you want to be able to vMotion the DAG. The VMs. Always update your NIC drivers, and please always update your VMware tools. The VMware tools is where we deliver optimization and all the drivers for the VM. If your VMware tools is out of date, if you call support, it's the first thing we're going to ask you to do because we know that outdated VMware tools will introduce performance degradation. So please pay attention to that. Use distributed virtual disk switches. It's easier for you instead of creating virtual switches on each ESX source. Just use VDS, and VDS makes it easier to configure networking for the ESX host. You may find some articles, some KB, some white papers online that tells you to not use VMXNet 3. Please disregard those. We try to kill all those, and we ask the Interpol to go and start searching for them. They're still out there. Don't use anything other than VMX3 NIC drivers. If you have any reason to suspect that VMXNet 3 is a bottleneck for you, please open a ticket rather than doing E1000 or E1008. VMX 3 is the best and greatest network drivers that we have today, and we highly recommend that you use it.
As an example there, Digi, VMX 3, a single VM can do 40 gigabits per second of throughput with a single virtual network card. So VMX 3 and lowest latency, so less than 50 microsecond latency. Yeah, sure. I've done a lot of tests with VMX 3 versus E1000. There's significant benefits with VMX 3 in terms of CPU usage as well. And especially for apps like Exchange, which are going to be using the CPU, that becomes very important. Okay, so let's look at some performance troubleshooting. We have a stack, and we have to be able to narrow down and isolate the different components of the stack where any problem may be occurring. So try and eliminate as many possibilities as possible. And we need performance at every single level. So the methodology of troubleshooting, understand the application, how it functions in the architecture. And then we need to know, the minimum, what does the application do? What is it dependent on? If there's any significant KPIs, like how long does it take for a message to be received and sent on an Exchange server? A lot of the things that happen in an Exchange environment, as an example, is if your storage starts slowing down, the mail queues will just start clogging up, and you'll get a backlog of messages that can very quickly get into the thousands to hundreds of thousands of messages that will take potentially days to get delivered to your users if the storage system is misbehaving. You need to definitely define a success criteria, do apples to apples comparisons. So a lot of people say, well, I'm testing one system and I've got this other system over here. It's just completely differently configured, but it's still apples to apples. And a lot of time it's not. It's apples to sheep. And sheep's something a New Zealander knows quite a lot about. We have about 40 million sheep. I wish they all had mailboxes and virtual machines. So we need to be able to do realistic comparisons between the two different platforms, and then find out where the gaps are. Now, most business critical applications, most virtual machines, most databases, 98% of the problems are related to storage somehow. In a virtualized environment, most of your problems are related to storage. Bit of delayed reaction there. Okay, so we've got lots of different places where we can monitor. We can monitor within the vSphere web client. We can monitor within vCenter. We can monitor within esxtop. And there's even a visual version of esxtop that you can get as a fling, which makes it a lot easier to interpret the data. And we can record that over time. So you can put esxtop into batch mode, and you record every 5 seconds the data that's going on in your network. Now, of course, with Windows applications, you can use perfmon, and you can use SCSCOM and other tools that you've got in your Windows environment to try and troubleshoot and isolate these issues. Now, these are the counters that you should be looking for. Now, in particular, these storage counters. So this is the device average latency. This is the kernel average latency. Now, this is measured in milliseconds, but that should never get over 0.001. So in other words, it should never be more than 10 microseconds in the ESXi kernel. So ESX is not adding any latency to your storage. If this goes up, it means you've got queuing going on in the hypervisor, potentially caused by the underlying devices. And then this is the guest average. So this is the end-to-end latency for your storage device, which will be a combination of these values here. Now, you should also look for the disk service time inside Performance Monitor, and you should also look for the average disk queue length inside perfmon. If those are getting high, then potentially you've got a bottleneck in your operating system before it even gets down below that. CPU ready should be always less than 3%. Okay. Memory, so here are the memory thresholds that you should be looking out for. Now, if you've reserved memory for your Exchange virtual machines, you shouldn't run into any memory issues whatsoever. You've guaranteed that performance to the Exchange virtual machines. Any business critical application, you should be guaranteeing the performance for your business users. And network, any drop packets are not going to be good. So if that's more than 0%, then you need to investigate why that's occurring. Now, a lot of the times, drop packets can be caused by driver problems, by firmware, and you can be getting a lot of paused frames in some of those scenarios as well. So always look for the driver and firmware of your network cards first before going up into the operating system. Okay, oops. Just skip this one? Yeah, we've covered that already. Okay, storage. Man, 15 to 20 milliseconds is really slow these days, don't you guys think? Realistically, for a database, we like to see less than 5 milliseconds. Now, Exchange is very tolerant for storage performance, so Exchange, anything less than 20 milliseconds is good, but for most other systems, 20 milliseconds these days is very, very slow. Right. A little bit of delayed latency on switching slides there as well. So here's an example using esxtop for these two different commands. We've got the disk average latency here, and then we've got the guest average latency here. And this is the example of the kernel should be, no latency at all. So by looking at this, we can determine that the storage platform under the covers is experiencing a latency problem. That could be, for a number of different reasons. This could also be because you've got lots of noisy neighbor virtual machines on the same host. Now, what we do in that situation, of course, is we enable storage I/O control. And if you've got a shared storage platform that's, traditional 3-tier, then you're enabling that. PVSCSI adapters, right? So the default queue for PVSCSI is 64 per virtual disk and 256 per adapter. That can be modified by registry entries, which I think.
Yeah, when you add a PVSCSI, we recommend that you use PVSCSI for your Exchange data disks, database, and the logs. When you use PVSCSI, please be aware that, you require VMware tools because the drivers for PVSCSI is not native to Windows. And on top of that, inside Windows, even after you've installed the VMware tools, you still have to tell Windows that I now have a super fast SCSI controller. Please start sending large I/O. The registry key right here is what enables that functionality. So don't just use PVSCSI and say, I'm using PVSCSI. Windows doesn't know how to use it unless you enable the registry key.
And then we can use up to 1,024 queues per virtual adapter, and if we've got 4 virtual adapters, it's a lot of I/O.
That's just a quick disclosure. Officially, we support PVSCSI on 6.0. If you're on 5.5, you can still use PVSCSI, even on 5.1. It is not officially supported, but it does work. We know customers that do it. 6.0, we have the checkbox that says, yes, it is officially supported.
Okay. So,
Microsoft does not support NFS. And because we want to always put you in compliance with your vendor, we do not support NFS for Exchange databases. We do not have known issue with NFS itself. It's just because you can't do it and get Microsoft support. In-guest iSCSI, you could do in-guest iSCSI. We do not have any restriction whatsoever on vSphere. You just be conscious of the fact that there is this very bad configuration option when you do Windows clustering. When Windows sees the NICs, it doesn't know that it's iSCSI NIC. Windows posts it into Windows failover cluster, which DAG relies on, and then you start sending Exchange packets over your iSCSI NIC. We always tell you, please be conscious of that and exclude your iSCSI NIC from Windows failover cluster. Otherwise, you're going to have performance problems.
Okay.
All right, so we told you, HA, DRS, Exchange DAG, everything, you can combine them. What about disaster recovery? Please know the differences. Exchange DAG is a very good high availability feature. It provides resilience for the databases. It is not the optimal DR solution, although there are some ways that you can configure Exchange DAG for DR. We will go through a little bit of simulation shortly. Active, when you hear that term, it's not usually, it doesn't mean what active is supposed to mean. Active just means that you can have two mailbox servers and they can be active. It doesn't mean that your mailbox is active in 2 places. Okay, distinctions. vSphere features do not interfere with DAG, so you can use DAG. Now, we will recommend, I don't want to go through HA and DRS. I believe everybody here knows what those means, and there are sessions that describe that in full. Now, Exchange uses Windows failover cluster. That is clear. Some people do not understand that. Windows failover cluster has a default 5-second threshold for heartbeat misses. So if you have two VMs, they're in the same DAG, they have 5 seconds they send heartbeat every second. If anyone misses 5 consecutive heartbeat probes, that node will consider the other node to be unavailable, and it will try to take over the resources. Okay, this can happen when you're doing backup. It does happen when you try to do vMotion if you don't follow our recommended best practices. So we recommend that you change that threshold to 10 seconds for vMotion purposes. We do vMotion very quickly in less than 10 seconds, actually in less than 6 seconds. But because it's 6 seconds and change, if you don't adjust this, when you vMotion your Exchange DAG VMs, you will cause database failover, unintended database failover. Please be conscious of that. All right. This behavior is not unique to VMware. It's not unique to virtualization. It also happens with our backup software that quiesces the Exchange server. Now, this is how you use Exchange with vSphere HA. I mentioned that DAG is good. When a database or a VM is not available, DAG brings up the database on another VM, and quickly you have access to your mailbox. So let's describe that. If you were on physical server, and you have these two nodes, and one of the nodes goes down, DAG will help you bring the mailbox up, but then that server is still down. You now have only one copy, and that copy is not protected until you service this one that's down and bring it back up. If you virtualize that infrastructure, what will happen is when that host becomes unavailable, we will automatically power on the VM that used to be on that host. We will power it on other hosts, and you will have DAG protection again in less than 2 minutes. This is how you combine HA with Exchange DAG. Disaster recovery. Disaster recovery implies that you have a whole site down. It's not one server failure or one mailbox failure or one VM failure. If you have a whole site down, you expect your services to come up on your DR site. Exchange DAG can accomplish that with some special configuration. Let me show you the example. This is what happens normally with DAG. So you have these two sites. You have VMs and mailbox servers running, and there is a failure. What will happen is that you will have to do some PowerShell commands, doing a data center activation to bring back services onto that other site. If you do the same thing with SRM, this is what will happen. You will have these VMs replicated over to your DR site. In the event of a failure, there is a button for you to push on an SRM to say recover. SRM allows you to pre-program all your recovery steps. SRM enables you to test your DR scenarios without bringing down your production. SRM enables you to see what will happen in the event of a real failure. You cannot do that with Exchange DAG for DR. If you want to test your DR with Exchange DAG, you will have to bring down production. There is no way to simulate a failure in Exchange DAG with DR. With SRM, what happens is we recover the VMs or the workload into a fenced network that doesn't impact the production network, and you can do all your testing in that fenced network while production is functional. Okay, so we recommend that you use solutions like SRM for your DR solutions and use Exchange DAG for your HA solutions. We do not preclude you from using DAG for DR. We just feel that it is more complicated to do disaster recovery with Exchange DAG.
Well, 5 minutes to go. We've got time for a couple of questions. There will be a mic roaming the room. But if you...
There's a question.
Yep, over
There's
here.
a question right there. The mic is coming, please. The mic is coming. Thank you.
So you were saying that Exchange is not aware about NUMA. So do you actually recommend to keep it in the NUMA domain?
So yeah, we didn't go into that details. That's a very good question. Should you keep your Exchange VMs within a single NUMA node? It is a good option. We do not want to artificially put you in that configuration. We recommend that you size your VM to NUMA nodes. However, if you use the Exchange calculator, and the Exchange calculator recommends, let's say, 16 CPUs, and you have a 2x10 hardware, we are not going to tell you that you can only use 10 because of NUMA consideration. Okay, we have all ways of making sure that you have NUMA locality where you can split the 16 onto 8 here and 8 here. Okay, we recommend that you try to size your VMs within NUMA boundary, a divisor of NUMA boundaries, or a multiple of NUMA boundaries. Not just one NUMA boundary. No, don't say my hardware has 2x4 or 4x4 and I can only give Exchange 4 CPUs. That's an artificial imposition that we do not insist on. Be conscious of the underlying hardware. If Exchange calculator says give your VM 9 CPUs and your hardware is 2x8, it is better for you to give it 8 than for you to give it 9, because the 9th CPU will be in a remote socket and potentially addressing remote memory. Remote memory fetching is very expensive. That's why you try to avoid overlapping NUMA boundaries. We are so flexible on vSphere. We give you advanced configuration option where you can split CPUs, vCPUs onto multiple sockets to have locality.
Got another question over there?
Very good question. Another question?
Yes, all your slides mentioned Exchange 2013. What about Exchange 2010? Is that also officially supported?
Yes. So before Microsoft officially supported DAG on vSphere with HA and DRS, when they released 2010, they were not supporting that. And we had to educate somewhat. I think you were involved in the process.
I was, yeah.
Anyway, after Microsoft released Exchange Service Pack, Exchange 2010 Service Pack 1, from there onward, they've been supporting everything, DAG, DRS, vMotion. So if you're on Exchange 2010, make sure that you have SP1, then everything will be supported.
And the time of value.
What?
And the time of value.
Yes.
Yeah, the time of value.
Even the Exchange
yeah, question
2007.
here?
It's the last question.
Thank you for your presentation. It was very valuable for us.
Thank you.
My question is, what VMware will add it for me as a customer if I use it for the Exchange instead of the hypervisor from Microsoft?
If you what?
If I use a VMware as a virtualization
Yep.
for the Exchange instead of using the hypervisor from Microsoft.
So is the question around support between Hyper-V and VMware?
Yes.
It's absolutely supported by Microsoft and also by VMware to virtualize Exchange on top of VMware vSphere. So the support experience from you as a customer should be identical because you've got a fully certified and supported solution.
And you would never find, well, if you do, please let us know. Microsoft would not express a preference for their virtualization option over other virtualization option. It is supported for virtualization, period. If as a VMware customer, you can feel confident that if you do it on vSphere, it will be supported by everybody.
Yeah, and half the audience here is already virtualizing Exchange, and they wouldn't be doing it if there were supportability issues.
Any other question? Thank you very much.
Thank you very
there's
much.
a question there.
When you were talking about disks, oh, sorry, don't need to shout. Okay. When we were talking about disk optimizations, you said about you talked about alignment, but
Yes.
how about block sizes? Is it still true you need to format them with the 64 block size?
So ideally, 64K block size on NTFS will give you potentially the best performance. Yep.
All right, thank you very much. You've
Thank
been
you very
very
much,
generous, very gracious.
Enjoy the rest of VMworld.